energy, matter, and cycle.
Everything in the universe is made up of matter and energy. Matter is anything that has mass and occupies space. Matter describes the physical things around us. The composition of the earth, the air you breathe, your pencil. Matter is made up of particles called atoms and molecules. Atoms are particles of elements, substances that cannot be broken down further. Matter consists of particles. These particles are called atoms. Atoms are the building block of materials. Atoms are made up of three types of particles: protons, neutrons, and electrons. Atom has a central nucleus with protons and neutrons in it. Protons is positively charged and neutrons has no charge, so the nucleus is positively charged. Protons and neutrons are collectively called nucleons. Electrons are negatively charged and located in the nucleus. An atom has the same number of negatively charged. The electrons added positively charged protons in the nucleus. Therefore, atoms are electronically neutral. Electrons are distributed in definite path around the nucleus called the shell or orbit. This concept was introduced by Neil Henrik David Bohr. According to Bohr, different electrons revolve around in the nucleus in the room of different orbits. The atom has been compared to the solar system. In an atom, the nucleus is the sun and the electrons are the planets. Just like in the planet of solar system, each electron revolves around the nucleus in its own different orbit. The maximum number of electrons present in a shell is given by the formula 2n to the power of 2, where n is the orbit number of energy levels. The first K shell has 2, the second or L shell have 8, and the M shell have 18 electrons. The electron present in the outermost shell of an atom is called valence electrons, and the shell which valence electrons occupy is called valence shell. A molecule is a general group of two or more atoms that is chemically bonded together. Atoms combine chemically by external forces such as heat and light. This leads to the formation of molecules. During the formation of molecules, atoms loses valence electrons or gain electrons from other atoms. For instance, if two pieces of wax join, they are heated of the heating of two pieces pressed together to form single structure. Heat is a chemical factor which is responsible for joining the molecules of wax pieces. There are two main types of bond, covalent and ionic. If a molecule is made up of atoms of the same element, it is called homoatomic molecules. If a molecule is made up of different elements, it is called heteroatomic molecule. There are currently 109 known elements, but obviously there are more than 109 different substances in the universe. This is because atoms of elements can combine with one another to form compounds. Let's take water as an example in which two hydrogen is combined with one oxygen to form H2O or water. There are three fundamental states of matter: solid, liquid, and gas. Solid is rigid, fixed shape, fixed volume. Liquid, not rigid, no fixed shape, fixed volume. Gas, not rigid, no fixed shape, and no fixed volume. Matter can change forms in two ways. First is physical change and chemical change. Physical change is a change from one physical state to another, in which there is no change in chemical composition. Melting ice cube, boiling water, and chopping wood are examples of physical change. On the other hand, chemical change involves rearrangement of atoms in the molecules during a chemical reaction. Example, the burning of coal involves chemical and physical change. The solid carbon of the coal combines with gaseous oxygen to produce gaseous carbon dioxide and water, B4. The energy locked up in the coal is released as heat. Burning wood, vinegar and baking soda mixture, and fireworks are some examples of chemical change. Now, let's move on to energy. What is energy? So, energy is the ability to cause change or to do work. Some forms of energy include light energy, heat energy, chemical energy, nuclear energy, electrical energy, and mechanical energy. There are two main types of energy: potential energy and kinetic energy. Potential energy is the energy that is stored, while kinetic energy is energy in use. To make us understand the concept of kinetic and potential energy, imagine you have a ball which you threw upward. As the ball travels upwards, we say that it has kinetic energy. Kinetic energy is the form of energy possessed by a body due to its motion. Therefore, anything that moves has kinetic energy, such as the car traveling on the road and the plane flying in the sky. Even you possess kinetic energy when you walk or run. In fact, the faster a body moves, the greater its kinetic energy. Therefore, when you run, you have more kinetic energy than walk. When the body stops, there's no more kinetic energy. When you come to stop or when the car stops moving, kinetic energy becomes zero. If we reach the ball at a certain height and release it, what happens? Start falling downward, right? It starts from the position of rest and it gains speed when you let it go. In other words, it starts with zero kinetic energy and gains some kinetic energy. Where does this kinetic energy come from? This energy, which is stored in the ball, is called potential energy. Potential energy is a form of energy stored in the body due to its position. Let's have a closer look. Here, the position is the ball height from the ground. When you release it, the potential energy converts to kinetic energy. In fact, the higher the ball, the larger its potential energy. That is why, if we raise the ball to a greater distance from the ground and release it, it will hit the ground harder. Let's look in another example. Look at the slingshot. It has stored energy which it can throw the bird up to certain distance. Based on the position of slingshot, we can say that the bird has potential energy. As soon as it is released from slingshot, it gains kinetic energy. And because of kinetic energy, it is able to apply force on the little houses to break them down. To summarize, potential energy is the energy due to its position. Kinetic energy, on the other hand, is the energy due to motion. Potential energy mostly depends on distance from the ground, while kinetic energy depends on speed.
The three laws of matter and energy.
The conservation of matter, conservation of energy or the first law of thermodynamics, and the second law of thermodynamics. Conservation of matter states that the mass of an object or collection of objects never changes over time, no matter how the constituent parts rearrange themselves. This means that the components of matter remains constant no matter how it changes form. For example, candles change form when they are born. It looks like the candle wax is disappearing, but it is not. Burning a candle turns the wax into carbon dioxide and water. Another example, when something burns up, the matter does not vanish. The material simply turned into gases you cannot see. Conservation of energy states that energy can neither be created nor destroyed, only converted from one form of energy to another, such as when electrical energy is changed into heat energy. Formally, it says that the total amount of energy in an isolated system remains constant, although it may change form. Example, friction turns kinetic energy into thermal energy. Second law of thermodynamics, given a pair of systems touching with different temperatures heat, will flow from hot to cold until the temperature of a system becomes equal. The second law of thermodynamics explains that it is impossible to have a cyclic or repeating process that converts heat completely into work. It is also impossible to have a process that transfers heat from cool objects to warm objects without using work. Example, a cold object in contact with a hot one never gets colder, transferring heat to the hot object and making it hotter. Furthermore, mechanical energy such as kinetic energy can be completely converted to thermal energy by friction, but the reverse is impossible.
Cycles of matter and energy transfer in ecosystem.
The elements from which all the organic compounds of the cells are made of are not in much quantity in nature. Therefore, they must be continuously recycled. Energy is produced by autotrophic organisms through photosynthesis and transferred through food chains at all levels of organisms. Connection to big idea about energy. The soil provides nutrients for plants and animals to survive. Food chains reveals how matter and energy is transferred within ecosystem. When nutrients decompose, they return their energy to the soil, perpetuating the cycle of energy transfer and transformation. Energy and matter in ecosystems are conserved. Connection to big idea about particles. Cycles of matter involve living organisms and non-living parts of ecosystems. Organisms obtain matter from their ecosystems and release matter or waste back to it. All matter that make up organisms pass through food chains and eventually decomposes into very small particles that will interact with others and form other types of matter and new organisms. Connection to big idea about the cell. Ecosystems are composed of millions of different organisms of different shapes, colors, and sizes, but are all made out of the same key element, the cell. Photosynthesis and cellular respiration provide the energy necessarily for life processes to occur. What is photosynthesis? Photosynthesis is the process used by plants, algae, and certain bacteria to harness energy from sunlight and turn it into chemical energy. Plants are called autotrophs because they can use energy from light to synthesize or make their own food source. To perform photosynthesis, plants need three things: carbon dioxide, water, and sunlight to make glucose, which is a form of sugar that plants need to survive. Cellular respiration, also known as aerobic respiration, is the process by which organisms use oxygen to break down food molecules to get chemical energy for cell functions. Cellular respiration takes place in the cells of animals, plants, and fungi, and also in algae and other protists. Cellular respiration is the chemical reaction in which glucose is broken down in the presence of oxygen, releasing chemical energy and producing carbon dioxide and water as waste products. Glucose plus oxygen to chemical energy plus carbon dioxide plus water. The energy release is captured in molecules of adenosine triphosphate or ATP, which then supply it to fuel other cellular processes. Thank you, and don't forget to click the notification bell and subscribe for more videos.